All right, and we determined that A is still doing the same thing. It tells us the width and the opening. We talked about the fact that if you get the equation and you want to get the vertex out of it, you recognize it's in descriptive form, you need to change the sign of H when you take it out, right? When you bring it out, you need to change the sign. That's what that negative is for. When you put it back in, it changes the sign again. So every time you transition, you change the sign of it, okay? So for example, if I ask you to state an equation with a vertex of -4, 5, right? You would then write it like this, but you would have changed the 4, the -4 into +4 if you write it into that equation, right? If you include it in the equation. So you got to watch out for that. And don't forget about the little square, or else it's not a parabola. It'll be a linear, okay? And then we talked about finding the Y-intercept algebraically, right? So this, by the way, can be done with any. You could find f of 2 or f of -2, right? You plug in -2 for x here, and then do the same thing. You're essentially finding the point in -2, whatever you get here, right? Because you're finding the y value given the x value, okay? That's really what you're doing. Okay, let's keep going. How many x-intercepts are there? A. Y is equal to -2. Oh, wait. Yeah, we'll do this and then I'll give you a general. -2 x plus 4 squared minus 5. So if I give you something like this, and I ask you to tell me just by looking at it, how many x-intercepts are there, right? The vertex, in this case, would be -4, -5. Again, I changed the sign of it. A is negative, opens down, okay? With these two pieces of information, right? Since K is negative, right, and A is negative, this graph will actually never cross the x-axis. Because think about it. If your vertex is -4, -5, right? -4, -5 is right about here. That's your vertex. -4, -5. And A being negative tells you that this parabola opens down, right? This will never, right? Therefore, no x-intercepts. Never crosses the x-axis. It never does. So just by looking at A and K, we can determine right away how many x-intercepts there are. In general, if A and K, okay, have the same sign, no x-intercept. So if A is positive, K is positive, A is negative, K is negative, you'll never have an x-intercept. If A and K have opposite signs, two x-intercepts. So you have A positive, K negative, or A negative, K positive. If they have opposite signs, you'll have two x-intercepts guaranteed. If K is equal to 0, A doesn't matter. One x-intercept. Because if K is equal to 0, right? If K is equal to 0, that means that the y value of the vertex is going to be on the x-axis, right? So it's going to go either like this or like this, right? It's just doesn't matter what A is, if it's pointing up or down, you're only going to have one x-intercept. So I would and keep in mind this is only for descriptive, okay? It says if A and K have the same sign. Oh, is that what you're referring to, Matthew? Yeah, it's the same sign. Sorry about that. If they have the same sign, opposite sign, and if K is equal to 0, it doesn't even matter what A is. Okay, you will have one x-intercept. Okay, I'm kind of counting for folks at home. Let's keep going. Given y is equal to 4.8 x plus 3 squared minus 6. Determine number of roots, and that is x-intercepts. B calculate the Y-intercept algebraically and with calculator. Sorry, it doesn't sound right, but I just wanted it to fit there. And with calculator to double check determine the Y value when X is equal to -3. No, let's go -5. Let's go -5. There. A, I recognize that the equation is in vertex form. So therefore, right, vertex is going to be -3. Sorry, it shouldn't be equal sign. It should just be like this, right? The vertex is -3, -6. Okay? A is positive, right? That's all I'm focusing on. A is positive, right? K is negative. Since they have opposite signs, the parabola has two x-intercepts. And we're gonna test that later and make sure we get that right. So a question like this, I'm gonna ask you to explain, right? I will say without using your calculator, determine how many x-intercepts it has, explain your answer. You'll have to somehow indicate that you're looking at the signs of A. A is always at the front, and you're looking at the sign of K at the back, right? So those two will tell you that, only if it's in vertex form, okay? B, calculate the y-intercept algebraically, right? X is equal to 0 at that point. So we're going to use that equation, right? We're going to say y is equal to 4.8, 0 plus 3 squared minus 6. That's 4.8. We know that this will end up being 9, right? Minus 6. 9 times 4.8 is 43.2 minus 6. That's 37.2. So the x-intercept is 0, 37.2. So you've basically determined the y value when x is equal to 0, right? It's just a different way of saying it, right? We're finding the x-intercept. Sorry, I said y-intercept. Sorry, folks, this is y-intercept, okay? Make sure you make a note of that. The y-intercept is 0, 37.2, okay? And we're going to check that with our calculator. So go ahead and type that in. Okay, so we go to y equals clear, and I'll type in 4.8 exactly the way I see it, x plus 3 squared plus 6, oh sorry, minus 6. I'm checking, double checking, just making sure I enter it right. Yeah. Then you hit graph. And right now I have zoom standard, I think. Yeah, mine is set to zoom standard. I'm just going to repeat one more time. When you're typing in manually, make sure plot 1 is turned off, or else it will conflict. There'll be a conflict. It will give you some kind of error. And that's probably the check right away, check to make sure that's off. Anyways, I'm going to graph again. I'm going to adjust my window so that I can see the y-intercept. So I need to go higher up, right? Y max needs to be increased. And because I know it's 37.2, I can just go to 50 or something like that, right, as my y max, and there it crosses. So we'll check, right? We will go second trace 1, x is equal to 0. So second trace 1, x is equal to 0, and there it is. Y is 37.2 as I expected, as we expected it to be. Okay. Let's continue. C. Determine the y value when x is equal to -5. X is equal to -5, right? So we're going to go y is equal to 4.8. You take your original, and it's -5 plus 3 squared minus 6. Okay. So you basically substitute x with -5. We're going to go ahead and find what the y value is. It is like, this is exactly like the length and width, like type 2 with the perimeter. You're plugging in an x value, you're getting a y value out of it. And so that's 4.8. This would give you -2, right? I would show that step there. I know that any negative number squared would always turn positive. So it's 4.8 times 4 minus 6. That's 19.2 minus 6. And that's 13.2. So -5, 13.2. This is a point on parabola. You just found a point, -5, 13.2 on the parabola. Let's say you're not sure. Graph. I'm going to go second trace 1. I'm going to type in -5 for x. And sure enough, it is 13.2, right? It is on the parabola. So you can do it with any value that I give you. Doesn't matter. This is algebraically showing step by step. Okay. Backside. Here we go. Write an equation that satisfies the following condition. The following conditions. A, you want a an equation with a vertex of -2, 4. You want it to be narrow, and you want it to have 2 x-intercepts. So this is just an example, right? If you want it narrow, you need a to be bigger than 1. So let's go with 3. And you're given a vertex, right? I will make a note here. Vertex is given right in descriptive form. Okay, vertex is given. That's why I'm going to write in descriptive form, because I know we've done this before in standard form, but if the vertex is given, you want to go by that, right? So it says that it's x plus 2 squared, because you have to change the sign of the x value of the vertex when you bring it in here. Okay, plus 4. And now you have to add a final touch. You can't argue with these two values, right? They are given to you by the vertex. You couldn't argue with this because it has to be bigger than 1. But you want 2 x-intercepts. What does that tell us? That A and K opposite signs. That's what that says. Okay? If you have 2 x-intercepts, you want A and K to have opposite signs. So now I'm looking at the sign of K, it's positive, so I'm going to make sure this is negative. Okay? So this is given to us. The 3 was needed to be there because it's narrow, so this could be 3, 4, 5, 6, 7, anything above. It could be 3.9, anything above 1. And the negative had to be there because of that. Okay? B. You want it wide. Points down. One x-intercept. You're looking at this, right? Like let's see, we're only looking at the first two. This could be done using the standard form, right? If I just gave you wide and points down, we could do that just with a standard form. But how can you guarantee me just one x-intercept, right? And this is where you should recognize, oh yeah, Mr. Dirksen told us there are 3 ways to recognize just by looking at it. So that's why I'm going to stick with vertex form. So the vertex form is, remember, right, this is what it looks like. I'm going to make this wide. So 0.5 is the best, your best go-to. I'm going to worry about the sign later. X, it doesn't say anything about the vertex itself, so we can just put in whatever we want. Squared. 1x is if this is 0, right? I'll make a note here. K is equal to 0, right? So we're just going to omit putting a 0 or anything down there. It's just not there. K disappears. Okay? A doesn't matter. Sign of A doesn't matter. Okay? What about the -2, Mr. Dirksen? What have you? Why did you put that in there? This could be anything. Could be anything. It doesn't matter. K is 0, right? And I make sure the square is there, and this makes it wide, right? A is between 0 and 1. And the sign could be anything as well. Like as soon as K is 0, it doesn't matter. Oh, it's you wanted to point down. Sorry, it is very specific, so it needs to be pointing down. Right? It points down. It is wide. K is equal to 0. That's why this would be having at 1 x-intercept regardless. Okay. Fill in the chart. And I'll tell you this, it has 1, 2, 3, 4, 5 columns. And I'm going to grab my ruler and I will kind of give you an idea. If you use the width of the ruler, right, I'm going to try 1, 2, 3, 4, 5. Yeah. So this will give you, if you have 5 columns, if you can fit 5 columns in there, that'd be great. And so I'm going to ask you to find the vertex. Min or max. Axis of symmetry. X-intercept or x-intercepts. Domain. Range. Y-intercept. And now I'm going to give you the equations up top. I hope you can see that. I'll zoom in a bit if this has a negative in front of it, folks. This last one is a negative. Okay. Let me just see here. I think I will leave you with this and a couple more questions to do. So I want you to fill in this chart. And I also want you to calculate the Y-intercept by hand. That's another way of saying algebraically. So I'm going to give you a bunch. I'll give you 3. So these are this is just stuff that I give you. This doing by hand is not really in the textbook. So the homework from the textbook is 417, 1 to 5, 9 to 15, as well as 18. At the end, you have some word problems to do. And trust me, the first couple questions just matching the equation. We match the equation with the graph just by looking at the vertex. Okay. One that I will show you. Sorry if I block you here. This is a very good exercise here. Question 5. It gives you 4 equations and you're supposed to match it to the corresponding graph. And it will really test your knowledge of the concepts, okay? Make sure you do that. That's it. Tomorrow I'll probably throw a little AC at you on this. And I will also give you the keys to this. Maybe I will scan it and post it so you will have that by today, okay? Other than that, I think, are there